Imagine a lone mechanic in a dusty, dimly lit barn, trying to build a single starfighter from scratch to take on a galactic empire. Operating completely alone, he pays full retail prices for every individual thruster and hull plate. He does all the welding and wiring himself, and the entire project is funded by whatever meager savings he has on hand. In economics, we measure production efficiency through average total cost, the total cost of all inputs divided by the quantity produced. For a single hand-built ship, the unit cost is astronomical. You cannot wage a galactic war when a single fighter drains your entire treasury. Survival requires a mechanism to drastically lower that per-unit cost. This tactical grid maps out the solution, the long-run average total cost curve. It charts cost per unit against quantity of output. Building a fleet costs more in total, but as production expands, the actual average cost per ship drops. This happens in the long run, a planning period where a faction is no longer locked into its current size. Every factor of production, from factory floor space to heavy machinery and specialized labor, can be freely expanded. Charting a strategic course down this left slope is the only mathematical way a small rebellion can afford to match the industrial power of an empire. As an organization expands, it experiences internal economies of scale. These are cost-saving benefits that arise strictly from the physical and strategic decisions made within the operation as it grows. This massive automated conveyor system at a Coca-Cola plant illustrates how large-scale operations leverage technical economies. Huge organizations can afford specialized, expensive machinery that spreads its high initial cost over a high quantity of output, reducing the cost of each individual unit. A larger fleet also unlocks purchasing economies. When you buy raw materials like hyperdrive components in massive bulk, suppliers offer deep discounts that a lone mechanic could never negotiate. Large, established organizations also benefit from financial economies. Because galactic banks perceive them as lower risk, they gain access to borrowed funds at much lower interest rates. Bulk discounts, automated machinery, and cheap credit are the physical mechanics that push a faction's position further down that cost curve. As the rebel fleet's expansion reaches the bottom of the U-curve, it hits a critical threshold, the minimum efficient scale. This is the optimal output level, where average total costs are at their absolute lowest and efficiency is maximized. Producing at this volume is the ultimate strategic goal, capturing the maximum possible savings without triggering the penalties of excess size. But then there is the Dark Overlord, who recklessly forces his factories to churn out ships far beyond that minimum efficient scale, simply to have the biggest empire. This chart reveals the stage of internal diseconomies of scale. The operation is now so large and inefficient that average costs start to rise as output increases. A factory the size of a continent suffers from communication failure. When orders take too long to travel through 15 layers of management, decision-making slows down and errors mount. Workers who feel like insignificant cogs in a massive machine lose their motivation, leading to reduced productivity and rising costs per unit. Simultaneously, overextended supply chains become diverse and chaotic, leading to a loss of central coordination and control. Poor communication and low morale create physical production delays. These inefficiencies drive the average cost of every single ship right back up. A wise mentor hiding in a swamp will tell you that some cost changes happen completely outside a faction's control, based purely on where they choose to build. These are external economies of scale, advantages that lower the long-run average costs for all firms in an industry as that entire industry grows. When shipbuilders concentrate in one sector, specialized tech colleges open to train workers, and shared infrastructure like improved roads and electricity supplies make every factory more efficient. On the tactical grid, this industry-wide growth creates a structural drop. The entire U-shaped curve shifts downward on the y-axis, lowering the cost floor for every faction in the cluster simultaneously. Locating near an industry hub provides a massive competitive cost advantage without requiring a faction to change its own internal size. But clustering too closely around the capital planet reveals the dark side of an industry growing too large in one specific area. These external diseconomies of scale occur when a cluster becomes overcrowded, driving long-run average costs higher for everyone involved. This image of dense street traffic and urban crowding captures the physical reality of external congestion. Skyrocketing rents for factory sites and fierce competition for resources force every local business to pay more just to survive. These external pressures force the entire LRATC curve to shift upward, penalizing every single firm located there, regardless of how well they are run internally. Galactic economic survival requires a dual strategy. Scale up internally to reach the minimum efficient scale, but stop expanding before bureaucratic bloat sets in. Strategically locate your operations to ride the wave of industry-wide growth, rather than being choked by its congestion. Ultimate power doesn't belong to the faction with the biggest numbers, but to the one that masters the economic law of scale.